So we're coming back, and we're going to continue with a new chapter on soil and environment quality, part 2, where this slide we're going to discuss mostly how to handle and how to manage the contaminants coming from the industrial side. Now, you might going to find out that this chapter, mostly we're going to discuss about waste management, which is also true. But we are going to touch a little bit on the impacts on the soil and how best we can manage this. So now, from the previous chapter, chapter 7, soil environmental quality in part 1, the content of the previous chapter talks about how to remediate the soil, which means in that chapter, the contaminants is already released to the environment and how best we can manage it. But in this chapter, part 2, we're mostly going to discuss ways to manage these contaminants before it's being released, which is why you're going to find out that this chapter probably involving more of the waste management, which is true. Here we go. Now, waste, as we know, coming from a lot of sources, and based on these different sources, they poses different danger because each of them will have different level of hazard. Domestic solid waste, if it's not due to the sheer volume, usually we don't care, we just dispose it in landfill. But nowadays, like as you know, we are running out of landfill, so that's why it is a concern. And for information, domestic solid waste, if we exclude the components that are supposed to be able to be recycled, most of our domestic waste consists of organic waste, and it say that 50% comes from a food source. So majority of it is moisture, organic from a source of food, and others. These others could be the unrecycled component like plastic, majority plastic lah, but still, by the way, plastic is still considered organic, yeah. Okay, next one, industrial waste. Now, this one is a bit problematic because industrial waste usually carry a certain level of hazard depending on what kind of contaminants is contained. So, if it's contained heavy metals or toxic organic contaminants, they falls under scheduled waste lah. And it is quite safe to say that all industrial waste, it will be considered automatically as scheduled waste, no matter how polluted is those contaminants. And then the other hazardous waste is medical waste. So this is biohazardous waste. And I'm sure nowadays we have a lot lah. From your mask is considered medical waste, you know, even though it does not come from hospital. A little bit lah, yeah. This medical waste most likely is due to plastic and manufactured items like I said, plastic polymers, okay? Polymers and also disposable items from organic cottons could be one of them. But it's quite safe to say from the events of COVID-19 nowadays, majority of our waste will be PPE, plastic, okay? And then what else? Your mask, right? Your mask also is a polymer, you know, it's not a cotton. It's a specially made polymer, which is not biodegradable, for your information. Your mask is not biodegradable. Similar with your wet wipes, diapers, these are like cotton-like materials, but they are not biodegradable because they are polymers. So of course, if they're not biodegradable, do you put in landfill? Usually no, they usually go to incinerator. Another reason why incinerator is because with heat, it kills all those pathogens. That's why most of our solid waste nowadays go to incinerator. Okay, next one is radioactive waste. This one, in Malaysia, I'm not sure where exactly it's produced. It can be anywhere because hospital use X-ray and they produce radioactive waste. Hospital is one. Rest of it, I don't think many industry in Malaysia having a lot of radioactive. Yeah, I think I know what. Previously, you know, like the rare earth processing plant, liners, yeah, they are the major contributor of this one. Because I think the only factories that deal with radioactive waste, the major one liners, yeah. Okay. E-waste management, it's quite safe to say, you recycle. And this flowchart tells you like how this is done. And it usually goes to a recycling collection center, and then it is distributed into several facilities, whether to break it down and use the small components wherever is possible. They don't break everything down into its material, They will try to salvage lah. See other components, electronics, there are a lot of components, memory lah, maybe processor. They actually recycle them. Now, if those components are also broken down, what they do, they break it down completely, and then they are going to recycle the material. Now, for information, these components inside there, they contain maybe some precious element like gold. In your smartphone, there is a very small amount of gold, and if you have enough smartphone, you can actually extract gold from there. Apart from gold, other elements like precious metal is gold lah, silver probably, platinum I don't think so. Yeah, but they contain a lot of rare earth. Yeah, smartphones. That also goes to computer and a lot of smart gadgets that we have nowadays. So that is a recycling one. But if all fails, if nothing can be recycled, then only we dispose. So I'm sure you know what are the 3 steps. These are the 3 steps that people use to manage e-waste in Malaysia. But let's say usually e-waste is such a pain. It's not worth to recycle, for information. If you're not very poor, rich countries like Australia, they always replace their e-waste. They always replace their gadget, electronic product. So they all ship to China. Last time they shipped to China because China accepts, they recycle, because that time they were poor, kan? But nowadays they're no longer poor. So they stop all this e-waste import. And you know where they go to? Guess correctly. It goes to Indonesia, previously Malaysia, now Indonesia. And now we're having a tough time trying to control this one, yeah? What we do, you don't have to go too far away. You go to any Shah Alam recycling plant, they need a lot of manpower. They need a lot of manpower in recycling e-waste. So there is job lah, but not the best job around lah. Okay, generation of e-waste is increasing. I think this one has been outdated for 10 years. I think now the numbers probably triple, if not quadruple, because of during this time, 2009, you don't have, this time is when iPhone just began. iPhone during that time is 5,000 ringgit. Now you can buy a smartphone for as low as 200 ringgit. So you tell how much of e-waste we have nowadays. Industrial waste, I think I will skip. I will not going to talk too much because I've talked so many times. Hazardous waste, it could be a lot of things, like I told you. This hazardous waste, it could be organic, it could be inorganic, similar to what we have discussed earlier. And the treatment also is quite similar. Remember just now, organic waste that I told you how to deal with it? You burn it in incinerator. Now, treating hazardous waste is no different than treating the hazardous contaminants in the soil. You can also burn it if you have organic waste. Do you use bacteria? Come on lah. Bacteria work so slow. Do you actually use bacteria in treating hazardous waste? The answer is no and yes. No means if it's in a recycling plant, no, you won't see bacteria. But there's one way. Sometimes hazardous waste, if it's organic waste, it can be bioremediated. But because bioremediation works so slow, usually people don't. They just burn everything off, solve the problem. Yeah? Okay, next one. If you have metal-based or inorganic pollutants, like I told you just now, you use acid or you use base to neutralize them. If the waste is acidic, then of course you put alkaline in, neutralize the pH and immobilize them. So by using by altering the pH to treat acidic and basic waste, it's akin of immobilization. The second point, it's close, very close to neutralization. It's in the treatment stage, but if you relate to what we learned just now on our previous chapter, this is almost like immobilization. Okay, third point, residues from the treatment and solid inorganic waste are bound tightly with lime. So yeah, this is the elaboration from the second point. Also, immobilization. So you see that they put limestone, calcium carbonate, or they put cement. Now, limestone itself will not going to solidify the so-called pollutant. They're only going to chemically lock the heavy metal. So in terms of structure, they do not have any stable structure. So in order to uh, further enhance, okay, the immobilization effect, you also increase the physical property. You enhance, you strengthen the physical property by adding more cement. I'm sure you know cement. You add cement, it becomes rock, and that's it. Everything locks inside the rock. So there you go. I mean, real treatment, not just use lime. You only use lime for the soil in the environment. However, if you're dealing with hazardous waste, you can do a lot more. Apart from adding lime to chemically immobilize it, you also can add cement to make like what we call some what's the best word? In Bahasa Melayu we call it jongkong. So it's like a batu bata. So yeah, bricks. So you can make bricks out of this hazardous waste after being treated with lime and cement. And this so-called bricks is available, but not to the public because of the potential health concern, guys. Okay. So after they have been treated with lime and cement, they will be deposited on a double membrane equipped landfill where there should be room for waste residue for up to 20 years. So most of the time, after hazardous waste has been treated chemically and physically, they will be stored somewhere. And this is what we call a secure landfill, in which after this we're going to go through. Yeah. So let's wait. Okay. So treatment of hazardous waste, heat treatment, physical, chemical, and biological. I have explained earlier, so you can hear from my previous video. And then recovery and recycling, this is the one that we prefer. This is what we call waste management by recycling. So this one, why recycling is preferred? Because the energy expenditure is very low. It is much lower than the others. Because when it comes to treatment, no matter what kind of treatment, using heat, using chemicals, physical, biological, there will be some expenditure to make. And when I say expenditure, is money. Why do we need to spend money? Because when you say heat, you need to buy fuel. When you burn fuel, that is where the expenditure comes. Even though the heat treatment only needs it, but you have to buy fuel to generate heat. Similar to physical and chemical and biological treatment. You need to buy chemicals to bring about this treatment. However, if you say recovery and recycling, what do you need? You need cheap labor. Yeah, you need cheap labor, like you send it to a cheap labor countries like China before this, now Africa. So these people are going to open up the components and then split the working parts with the non-working parts. So in other words, money expenditure is not that high. The other one is solidification, including stabilization. This, to me, is part of number 2. Solidification and stabilization comes under chemical treatment, because these are the ones that you treat. And what do you need to treat it? You use cement, you use lime, so it comes under here. It's actually the same thing. Okay, radioactive waste is not something that we deal every day, and because their nature is a bit, not a bit, quite different. Because compared to the toxic elements that we discussed earlier, radioactive waste have one more problem. They also emit radioactive wave. It's like a dangerous ray that radiates from the waste. Now, these electromagnetic waves are gamma ray, alpha, beta, and gamma radiation. These three have different rates of penetration. But when it reaches your cell, the damage is your cell DNA. And when your cell DNA is damaged and not repaired, it will give you cancer. So that's why radioactive waste, their danger is not just the toxicity of the elements, but they also come in a form of their radiation. They will shine out, they will radiate the dangerous electromagnetic field. So what do we do is quite simple lah. If it is if it can be immobilized, so first of all they will be surely immobilized. Maybe there's some cement involved, but I'm sure cement is one of them. Because why? Radioactive waste, if it is in cement, they are virtually stabilized and they can no longer radiate of radioactive waste. But the problem is, almost all the time you're going to need to use cement, and cement, for information, is not cheap, you know. So radioactive waste is such a problem. But this is the way they treat it. They mix this radioactive waste with cement, immobilize them in a cement form, solid, and then they will need to be transported in a secure landfill. So it's a landfill. It is secured with a lot of concrete, very thick concrete, and it stays there for as long as it takes lah. So I believe Pahang have one, but so far they not sure where exactly they built this secure landfill, but I'm sure like it's near Gebeng lah. It's not too far away. So that is the way that people solve the radioactive waste. So landfill disposal of non-hazardous waste. So what we call non-hazardous is relatively not hazardous. You cannot say that municipal solid waste is not hazardous. No, it is hazardous, but relatively non-hazardous compared to those scheduled waste. So what do we do? First of all, you need to know what's municipal solid waste. So as you can see that mostly organic. Here they say 70%. I believe this one is, it depends lah. Yeah? It could be as high as 90%, it could be as low as 30, 50%, depends on the place lah. Now, majority is organic waste. It's not just paper, cardboard, yarn waste, but that also includes plastic. I believe majority are plastic lah. Some of them are glass. Usually glass is not a concern because glass usually they're non-toxic. Right? What is our concern is plastic. Plastic plus metal, because these two are supposed to be recycled. But I think you learn the reality, guys. UK, Western countries, they all export their plastic to Malaysia so that we can dispose it, which is not too smart lah to me here. So plastic is considered organic pollutants, but it is not biodegradable. Metals, they may be the source of heavy metal contamination in the landfill. So what do we do? According to the laws provided to us, I think there are new laws that mandates recycling of air for majority of the local government in Malaysia, in which whoever who fails to recycle and sorted out the recyclables like your plastic, your metals, you can be fined. So far, haven't seen any people get fined lah. So again, Malaysia problem, we have laws, but the implementation, don't need to say lah, yeah. Okay, so these are the things that the laws has provided us, in which majority of them actually encourage us to recycle. For those who cannot be recycled, like organic waste, last time they say they want to put it in landfill, but I think nowadays local government also wants those organic waste so that they can produce compost. Now there are two major local government in Malaysia that actively doing that. Number one is MBSA, Majlis Bandaran Shah Alam. They are one. The other one is MPSJ, Majlis Perbandaran Subang Jaya. These two, they actually have enough funding to create a plant for composting. So for you guys who want to do LI after this, these are the two places that's worth going lah, because they really like do all this composting work from municipal solid waste. Of course lah, these are history because you no longer see this one. The last time I see this was 10 years ago in UITM, where there are 3 of these bins exactly under block B. So what happened to them now, I also don't know. Last time that I see it, when I open in Kacha bin, I can see cigarette butts. In Kertas, I also can see plastic wraps of food. So a lot of flies going in. So macam-macam lah. I mean, we have the laws. It's just the implementation and the people's reception is not that satisfactory lah. Yeah. So what happened to those bins? They're gone forever. Don't know where they go. Okay, purpose of landfill. Now, landfill is used to treat organic waste. And in this case, we're talking about municipal solid waste. So assuming the most ideal municipal solid waste consists of majority of organic coming from food source, so they are very good for landfill. Because why? All you need to do is pour all those organic waste in the landfill and close it and let the bacteria do its job. So that is a purpose. That's why municipal solid waste are not supposed to contain plastic, because it won't work. It will only work if it is all biodegradable organic waste. So this is good to treat those waste. And well, we have two types. If it is municipal solid waste, we use natural attenuation landfill. If it contains some hazardous or scheduled waste, then it goes to secure or containment landfill. So there are two types of landfill. Their construction is different, their requirement is different, and more importantly, the ways that they treat or they handle also is quite different lah. Yeah. So what is natural attenuation landfill? It is actually relying mostly on indigenous bacteria. That means the bacteria already in the soil to conduct all those decomposition and degrading process. Like for example, if the municipal solid waste consists of food waste, I think the food waste itself already have all those required microbes to do the job of, of degradation. So what they do is they just leave it in landfill, close it, and inside the soil, the bacteria will slowly degrade it until it is stabilized. So once it's degraded, it becomes probably fertilizer lah. That is the point, which is why natural attenuation landfill, they do not have a like a boundary, we call it. A boundary is like a wall. Usually when you build a house or a structure, you have walls, kan? But natural attenuation landfill, they do not have that. They probably have like a bottom layer. They probably have a bottom layer to decrease or to limit the outflow of leachate. Now, leachate is a liquid wastewater from the overflow of landfill. Now, of course, when you have rain will seeps into landfill. They may dissolve and leach out dangerous chemicals out. So this is what we call leachate, this wastewater. Some naturally attenuation landfill may have this kind of layer to stop it from overflowing. But according to this NOSLA, they actually don't have it. In fact, they rely on the soil to naturally absorb this leachate, and again, relying on the bacteria, the microbes already in the soil to remediate the contaminants. So do you see the problem? The problem is that never once landfill leachate is free of heavy metal. So that's a problem lah. If the landfill have heavy metal, then it defeats the purpose. So listen carefully. This natural attenuation landfill is for handling organic degradable waste. Organic degradable waste like food. Yeah. So they are not meant to handle hazardous waste like plastic, heavy metals, hazardous waste. No, this is not suitable at all. Yeah. Because there's another type of landfill, we call it natural attenuation landfill. Now, in this case, it is constructed with a reasonable feature. Now, this feature includes retention walls that are built with cement, concrete, and they also have flooring that prevents the escape of the escape of leachate if they have. But most of the time, they don't even allow inflow of rainwater. They are just like a structure, underground structure, where they have secured access. No water can flow in. So this is usually used to store all those drums that contains treated hazardous waste. Like for example, if you have like a mercury contaminated waste, they are limed first and then they put into a cement and into a drum. So after that, what do they do? They just transport it under this landfill, the secured landfill, and keep it there. The reason why this is so is because heavy metals or the hazardous waste, most of the hazardous waste after they were stabilized, they may have a risk to be released again. Because whatever that you do, if it is immobilization, it can be released under certain conditions. Heavy metals, you raise the pH, you immobilize it. But what happens after you have acid rain, where acid comes back in? If the acid comes back in, all those heavy metals, the toxic elements may leach out again. So to prevent that from happen, that is why most of them, after treatment, they go into natural attenuation landfill. So the construction is they have a wall 1.5 meter. Not the wall thickness. This is the Okay, this is a requirement to reduce the risk of groundwater contamination. Usually they have a clearance, of between water table, groundwater table, and also the bottom of that landfill. So there must be at least 1.5 meter of clearance so that it is not too close to the water table, that if there's an event of accidental leach, it will go straight to the groundwater. Because why? Whatever that's in the whatever that's in the landfill, uh, they will need to be contained. Okay, now so this is what you can see, the natural attenuation landfill, in which you can see they are not supposed to have all these layers. In fact, even if they have these layers, they will be like clay, just clay. They're not plastic or maybe concrete. So natural attenuation, they still use clay as lining because clay can stop inflow and outflow. So leachate may be deposited. So that's why I say 1.5 clearance, so that the leachate may not go down. But here's the thing: if you have the natural attenuation, you're relying on the bacteria to do all those decomposition. They may produce gas, so there might be some gas being produced, so they will be like channeled out. Maybe it's going to be reused for the methane or whatever. So this is what they do. On the surface, they're going to plant with phytoremediation. They're going to conduct phytoremediation, plants that can absorb moisture and also can absorb all these contaminants. Okay. So next thing is the containment landfill or secure landfill. So this secure landfill, like I told you just now, whatever the treated hazardous waste, they put in drum and they put inside. So I would say this is how it looks like. So they will have clay. Some of them very thick, but to be sure, I think nowadays most of the secure landfill, if it is involving radioactive waste, they will be concrete. So these so-called walls are the barrier or the boundary of this secure landfill. They can be clay, they can be concrete, they also can be a layer of plastic. So a lot of things can be used. Why? They are trying to stop the inflow and also outflow of rainwater, so that nothing goes in, nothing goes out. Because if there are moisture goes inside, these drums may be corroded and they may release the contaminants. So this is like a jail. You can say it's a jail to store all those treated hazardous waste so that it stays there forever. It's meant to be stay there forever and not to be discovered. Yeah. Okay, not too different, kan? But the so-called the waste that they manage is quite different. And I think you can guess lah, secure landfill is more expensive than the natural attenuation landfill because costs coming from the construction of the wall, and also you may need to like have like a stabilized uh, stabilized flooring. You may need to construct different floors with some flooring, so cement investment. Also these are the material construction materials that needs a lot of investment comparing to this one. You don't even need flooring. You just dig a hole and then municipal solid waste, dump it. After one day, then you capped it. This capping also is clay. It's not plastic, it's clay. So or if it's not clay, it's the soil around it. You just use soil, compost, close it, and then you continue until this whole landfill is completely filled. And after that, you close the landfill, plant with a lot of hyper accumulators, plants. That's it, close. So this one is not sustainable, I have to say, because you cannot allow the bacteria to do its job. So these contaminants was forever locked inside in this so-called jail, the secure landfill forever. So that's why lah. So do you know what? We have two. At least I know there are two. Number one is operated by liners. They were there specially to store those radioactive waste, treated radioactive waste. And there's another one, which is in the mountains of Perak, Bukit Merah, if I'm not mistaken. Now, Bukit Merah used to have, listen carefully, Bukit Merah used to have a natural attenuation landfill to store radioactive waste. That was a story lah. If you have time, you go and search lah in Google the story of Bukit Merah in Perak and also rare earth. I think you can hear a lot of story from there. I will stop from here. You will discover yourself. And there has been a long story. I think recently it has been resolved, in which that area that has been contaminated with rare earth, all those soil, they were brought to a place, stabilized, and then stored in a secured landfill in the middle of somewhere. They never disclosed the location of this secure landfill. So all those contaminated soil, they will keep in a secure landfill somewhere in the limestone hill in Perak.